All right, let's get into this. We're always looking to the oceans for big answers, especially when it comes to clean energy. And you see the tides, this massive, predictable power, and you think, that's it, that's the solution. But what if that solution has a dark secret? A danger we've just completely missed, hiding right in the basic mechanics of our planet. I mean, on the surface, this question sounds kind of silly, doesn't it? Of course it is. The moon pulls the water, the tides come in, the tides go out, we just put a turbine in the middle of it. It feels like the perfect natural engine, one that's going to run forever. It's a real poster child for our green energy goals. But here's the twist. According to the research we're digging into today, that entire way of thinking is fundamentally flawed. A paper by a scientist named Jerry Z. Liu argues that far from being renewable, harnessing tidal energy on a large scale could kick off an environmental disaster that would make global warming look like a walk in the park. And look, this isn't some brand new idea that just popped out of nowhere. No, this is the result of one scientist's fight for decades to get this warning out there. And it's a warning that's been met with a lot of pushback, not really from other scientists, but from the industry itself. Now, this is where it gets really interesting, because it shows you the conflict at the heart of this. Back in the 90s, Lou put up a website to explain all his findings, and he says he got direct pressure from companies to take it down. So right away, you've got this classic setup, a serious scientific warning clashing with some powerful business interests. So to really get what this warning is all about, we have to go back to basics. We got to ask a question that, honestly, most of us have probably never even thought to ask. Where does the energy that drives the tides actually come from? And here's a hint. It's not the water. Okay, so it all kicks off with gravity. You've got the moon and the sun pulling on Earth, and this pull creates these two big bulges of water on opposite sides of the planet. One bulge is getting pulled right towards the moon, and the other one pops up on the far side basically because of inertia as the whole Earth-Moon system does its dance. And right here, this is the key point that changes everything. Those bulges of water don't actually race around the planet. Nope. They stay more or less in one place, held there by gravity. It's the Earth itself, the solid ground, that is spinning through them once every 24 hours. So what does that mean? It means the energy we see in the tides isn't coming from the ocean. It's being pulled directly from the Earth's spin. The scientific name for this is rotational energy. You can think of it like a giant planet-sized battery. It's a massive power reserve, for sure, but it is absolutely finite. And every time we harness tidal power, we're making a withdrawal from that battery. Okay, so how does this actually drain the Earth's energy? How does it work? Well, the paper uses this fantastic analogy that makes this huge planetary concept super easy to wrap your head around. Let's break it down. This illustrates it perfectly. Think of the spinning Earth like the big metal rotor in your car's brakes. And those stationary tidal bulges, those are the brake pads. So as the Earth spins, the ocean floor is constantly dragging against this bulge of water, creating this incredible amount of friction. And that friction, it acts like a brake, constantly, steadily slowing our planet down. And this isn't just a theory, we can actually measure it. We know from fossil records that 430 million years ago, the Earth spun way faster. A year had something like 420 days in it. This natural braking is slowly making our days longer, and eventually it'll cause the Earth to become tidally locked with the moon. But here's the crucial part. That natural process is supposed to take about 10.5 billion years. So nature is already gently tapping the brakes, right? The question is, what happens when humanity decides to come along and just slam its foot on the pedal? This is where the calculations in the paper get seriously alarming. The scenario is pretty simple. Imagine we go all in on tidal power and manage to generate just 1% of the entire world's energy needs from it. Just 1%. I mean, that sounds small, right? Responsible even. A safe little test. But that 1% represents a huge amount of energy we're pulling out of the system. And by doing that, we're adding our own powerful artificial brake on top of the natural one. We're not just letting the planet coast to a stop over billions of years anymore. We are actively draining its battery at a terrifyingly fast rate. So how fast is fast? According to the paper's math, based on how our energy use is growing, it would take just 1,031 years to drain enough of Earth's rotational energy to cause a full tidal lock with the moon. I mean, just let that sink in for a second. The natural way of things takes 10.5 billion years. giving life all the time in the world to evolve and adapt. Our plan would compress that entire timeline into a measly 1,000 years. We'd be cramming billions of years of planetary change into a time span shorter than the history of some religions. It's insane. So what does a tidally locked Earth even look like? What does it really mean? It's not just that the days get longer. It would completely break our planet's climate and shatter every ecosystem we have. Get this, a single day-night cycle would stretch out to last for an entire lunar month. We're talking over 700 hours long. That means any spot on Earth would bake under the sun for 2 straight weeks and then freeze in total darkness for the next 2 weeks. You'd basically create 2 totally separate, hostile worlds on one planet. The side permanently facing the sun would be scorched into a lifeless desert. The dark side would become a frozen, barren wasteland. The only place life could maybe exist would be in a tiny, chaotic twilight zone between the 2 extremes. And the final result? Well, the insane temperature difference between the hot side and the cold side would create permanent, planet-sweeping superstorms. The climate as we know it would just stop existing. Ecosystems would utterly collapse, leading to a mass extinction of pretty much everything. So, the takeaway here isn't just tidal power is bad. It's a much bigger warning. It forces you to ask, in our desperate and totally necessary race for clean energy, are we moving too fast? Are we so focused on solving the fossil fuel problem that we might be about to blindly stumble into another catastrophe, one that could be even worse?